reverse percentages. In fact, we're going to deal with it in exactly the same way as we deal with percentage increases and decreases. So let's see. The first thing we're going to do is we're going to identify before and after quantities. That's before the percentage change and after the percentage change. And then we're going to find the after percentage. So what have we changed to? Well, if it's a percentage increase, we add the given percentage to 100. And if it's a percentage decrease, we subtract the given percentage from 100. So if it was a 5% increase, we'd end up with 105%. And if it was a 5% decrease, we'd end up with 95%. And then we're going to write down a statement connecting the before and the after. And that's going to read something like this. After is a percentage of before, using the percentage we've just found. And then we're going to translate that statement into an equation using the decimal equivalent of the percentage. So 95% would be 0.95, being 95 over 100. And remembering that is means equals. And then we simply substitute in the numbers and solve the resulting equation. Okay, let's see how that works in practice. So in a sale, prices are reduced by 30%. And so we have an after percentage here, don't we? Which is 70%. Before quantity is perhaps the original price, okay, which is highlighted here. And the sale price is our after quantity. And so now we can write down our statement. The sale price is 70%, so that's a reduction of 30% of the original price. And we can now turn that into an equation. Sale price, let's call it SP, is, so that's equals 70%. Percent means divided by 100, so that's 0.70 or 0.7, which is the decimal equivalent of 70%. Of is always times original price, OP. And now we can just put in the number that we know. We know the sale price of a jacket, it's $280, and that's 0.7 times the original price. And we have an equation to solve. We want the original price on its own, so we divide both sides by 0.7. The 0.7's on the right cancel, that's rather the point of doing it, and we get the original price is 280 divided by 0.7, which is very expensive for a jacket, maybe $400. Right, let's try one more and see how we go. So now we have Lionel, and he's buying an antique cow creamer, whatever that may be, and he's sold it for a 40% profit. So he's got the price he sold it for and the price he paid for it. So a selling price and a paid price. And the after percentage, well, it's a profit, so it's an increase, and it's 140%. So it's a 40% increase. And our statement is, well, we've got his selling price is 140% of the buying price. And that sums up his transaction very neatly, and we turn that into an equation. So the selling price is equals 140% divided by 100 is 1.4 of times the buying price. And again, we can just put the numbers in. So it's sold for 280. That's 1.4 times the buying price. How do we find the buying price? Well, we divide both sides by that 1.4, which of course means the 1.4's cancel, and I get buying price equals 280 over 1.4, which is £200. So he's bought it for £200 and he's sold it for £280, which is a 40% profit. We'll just do one more because this one's slightly different. So the same chap, Lionel, has bought and sold an antique pipe tamper. Very useful if you smoke a pipe. But this time he hasn't done very well. He has lost 20% on the deal. Now we need to be a little bit careful here because we've got a loss of 20%, which we might think is an 80% decrease. Sorry, 80% of what we want. But actually we're talking about an actual loss and how much he paid for it. So 20% is right, because we're going to say the loss is 20% of what he paid for it. Okay, so the buying price, if you like. So we just need to be a little bit careful sometimes that we are dealing with the right before and after quantities. In this case, it's not the selling price, but we are dealing with the loss. Now we could carry on as normal and we say loss equals 0.2, because that's the decimal equivalent of 20%, of the buying price. And 16 is therefore 0.2 times the buying price, and we solve as normal. Divide both sides by 0.2, which has the normal cancelling thing going on, and the buying price is 16 over 0.2, which is £80. So he has bought it for £80 and he's lost 20% of that, which is £16. And that is how I would do reverse percentages.